Hello everyone, my name is Yamini Shale and I am the subject matter expert at Fice Education Private Limited, and today I welcome you all for Serial Communication Protocol I2C and its applications in IoT webinar. Before going to discuss about this particular webinar, let us have a look at our agenda, that what we are going to discuss for today's this webinar topic. And firstly, I am going to tell you the recap of our previous webinar, and then I am going to introduce the I2C bus and then protocol format of I2C, and then we are going to discuss some API functions which are related to I2C with respect to Intel Galileo platform, and we are going to discuss about some sensors which are based on I2C interface and the applications of those sensors which are based on I2C bus. So in our previous webinar we have discussed about the serial communication protocol and parallel communication protocol and the difference between serial and parallel communication protocol and some examples of serial communication protocols like UART, I2C and SPI. And in our previous webinar we have introduced UART serial communication protocol, and in this particular present webinar we are going to discuss about I2C serial communication protocol. I2C stands for Inter-Integrated Circuit Bus, and I2C is a small area network which connects ICs and other electronic systems. Originally, I2C bus intended for operation in one single board PCBs, and this I2C bus is a synchronous serial signal, and it requires two wires to carry the information between a number of devices. That is, one wire is an SDA and another wire is an SCL. SDA is a serial data line and SCL is a serial clock line, and serial data line is used for the data transmission and serial clock line is used for the clock. And master is a device which always drive the clock line, that is serial clock line, and also the master device initiates a transfer by generating start and stop conditions, and also it transmits the slave address, and also the master device determines the data transfer direction, whereas the slave are those devices which always respond to the master. Nowadays, a variety of devices are available with the I2C interfaces like microcontroller, EEPROM, real timer, and some chips, LED drivers, and A to D converters. Coming to features of I2C bus, those two wires, that is SDA and SCL lines, make it possible to support serial communication of 7-bit and 10-bit device slave addresses, and also I2C bus has a support for 8-bit data bytes, and also the I2C bus has a support for control bits for controlling the communication start, stop, direction, and for an acknowledgement mechanism. So considering these control bits, let us discuss in depth, that is, these are the control bits like start, address, acknowledge, data, and then stop. Start is a device, start is a bit or it's a control bit which has been generated from the master when master wants to have a communication with an slave devices, and then it master address is that one, master sends this address of the device to which device it want to access, and then once the master or the address of that particular device matches, in response acknowledge signal is generated and master starts transmitting or receiving the data, and then again once the data is received or sent properly, an acknowledgement signal is generated, and then after success of transferring the data or getting the data, then the master device will generate an stop condition. In detail, if you want to discuss in detail information of these control bits, start is a bit. Master will generate and start of this particular I2C communication. It want to access any slave devices, whether it may be for writing purpose or whether it may be for reading purpose. So once it starts the communication, it has to give the slave address of 7-bit, means which slave device it want to access. The master has to define that particular slave device by selecting the slave address. And then read write bit. So when a master wants to receive data from a slave, it sets this read write bit to a logical 1. When master wants to send the data to slave, it sets read write bit to logical 0. And then once the slave address of that particular slave device has been matched successfully, an acknowledgement signal will be generated from the slave device saying that the slave device is ready to get the data or to send the data to the master device depending upon the read write bit. Once the master device receives an acknowledgement signal from the slave device, it sends an first byte of data, and once the byte has been transferred or received from the slave device successfully, again slave device is going to generate an acknowledgement signal saying that the data has been received or the data has been transferred successfully. Once the same acknowledgement signal has been received from the master device, then again master is going to send a second byte of data to an slave address or to an slave device. Again same, once the data has been transferred successfully to the slave device, again slave device is going to generate a acknowledgement signal, and once the master has received the second acknowledgement signal from the slave device, then it will generate an stop condition saying that successfully the data transmission has been done. So you can see here in one cycle the master first has to select the slave address, then it has to select the read or write bit, then it has to see the acknowledgement, and depending upon those acknowledgement it has to send or receive the data to the slave devices. Once it is done, it will going to create a stop signal just to stop this cycle of communication. So you can see here in one cycle I2C protocol transfers only 2 bytes of data, not more than that one. So this is very important here. Coming to a Galileo board, if you have any sensors which are based on I2C, where we need to interface is the SCL and SDA devices. So you can see here on the topmost of the digital pins we have 2 pins, that is SCL and SDA. So by using these 2 pins, any I2C based sensor can be interfaced to Intel Galileo Gen 2 board. And coming to some API functions of Intel Galileo platform with respect to I2C communication protocol, a library called Wire is already there to support the I2C interfaces, and this Wire library, it has been written in C++ language, and some functions like begin, request form, begin transmission, end transmission, write, available, read, on receive and on request. So these are the some functions which are related to I2C APIs, and then these functions we are going to discuss now. And here you can see here the send and receive have been replaced with read and write bits. So coming to in depth of these informations, first is an Wire.begin, and this is most important function. It must be called to start any I2C communication using the Wire library, and that is a Wire.begin, and there is no any argument specified. If there is no any argument is specified, then I2C bus will join as a master. If any argument is specified, it is an 7-bit address of your slave device. If it is mentioned, then the I2C bus will act as a slave device. Then if I2C master or a device, if it want to get the data from the slave device, the first and foremost function is wire.request from, and it takes two arguments, that is address and byte. Wire.request, it requests slave devices to send the data in terms of bytes. So first argument is the address. We have to mention from which slave device we are going to get the data. The slave address has to be mentioned in a first argument, and the second argument we have to mention that how many numbers of bytes we want to get from the slave device that master has to initialize. Once it selects the slave address and bytes, how many bytes of data it want to receive, then it has to see whether slave device is available to give the data or not. So for that the function is y.available, and then returns the number of bytes which are available for the retrieval, y.available. So this act as a acknowledgement signal. Once the acknowledgement signal is generated, then the master device have to read the data from the slave device by using the function wire.read. So these are the functions which are used for to get an data from the slave device. Now we will discuss what all the functions will be used for the sending or writing the data onto the slave device. The first is the Wire.begin transmission, and it takes an one argument. So begin a transmission to the I2C slave device with a given address. It means the address is of the slave device. The master I2C bus will begin the transmission from that particular slave address, and once it has chosen the address of that particular slave device, now it has to transfer those values what it want to write onto that particular slave device. For that the function is wire.write, that is value. The argument it takes is value, and this value is depending upon the data, what data the master want to write it onto the slave device. So once after selecting the slave address, once the transmission has been done, we can give an end transmission by using the function called as y.end transmission. So if this function becomes true, it sends a stop message after transmission and releasing the I2C bus. So these are the some API functions which we can use to write a program for the I2C based sensors to get the information from those sensors. So if those I2C based sensors we are going to discuss is accelerometer, gyrometer, and some digital temperature sensors. An accelerometer has three separate internal accelerometers mounted orthogonally, allowing us to analyze separate components of complex accelerations, and this 3-axis accelerometer is used to give or measure an acceleration due to gravity towards x-axis, y-axis, and z-axis. In the same way, another sensor is 3-axis gyrometer, and this 3-axis gyrometer is a device which is used for the navigation and measurement of angular velocity. And a digital temperature sensor which is used to measure the surrounding temperature. Coming to applications of these sensors which are based on I2C is, if we can take it in a field wise, that is engineering field, accelerometers can be used to measure the acceleration of vehicle, vibration on cars, machines, buildings, process control systems, and safety installations. For example, we can take it as a airbag applications in vehicle safety. The main purpose of this airbag application is to provide the occupants a soft cushioning and restraint during a crash event to prevent any large forces between the failing occupant and the interior of the vehicle. During a crash event, the vehicle's crash sensor provides a crucial information to the airbag electronic controller unit. Once the once it receives the information from these sensors, the airbag electronic controller unit determines if the crash event meets the criteria for deployment and triggers the various firing circuits to deploy airbag modules within the vehicle. If we are going to discuss the application in the industry, accelerometers are used in machinery health monitoring system to report the vibration and its changes in time of shafts at the bearings of rotating equipments. Nowadays, equipment reliability has become a vital focus within any organization or any industries that count on the availability of large machinery. When system suffers breakdown or fail, it can affect the overall functionality and operation of a facility. Hence, machinery health monitoring system has become an important in all the industries and all the organizations. Coming to healthcare industry, accelerometers are used to measure the speed and distance of the wearable devices to calculate gait parameters such as stunts and swing phase. So nowadays we all know that the wearable technology is expected to deliver valuable services to their users to help to drive a better lifestyle. Specifically, the wrist-worn wearable devices requires to deliver the wellness and fitness related services. So in such wearable devices, accelerometers, gyroscope, magnetometer and pressure sensor processing is essential for the smartwatches and activity trackers. So like this we can have many applications on those sensors which are based on I2C. So we can have a visit for our Intel website where you can get more information on the Internet of Things and the Intel Galileo Gen 2 board. You can even contact us on info@fice.in, that is info@fice.in, and also you can even contact us on mentor@fice.in. Even you can visit our website on www.fice.in. Thank you.